Hey guys, it's Mrs. Dugan. So today we are going to be talking about the different layers of the earth. So, yay! All right. I know most of you have experienced this before and have learned on it. So this should be a lot of review with maybe a little bit of sprinkle of tidbits along the way. But starting off first, if you submit this to me, you will get your paper copy that you can have in your gus. Okay, that's important. You're gonna want that paper copy. Okay, if you don't have that paper copy, you're gonna really regret it towards the end of the week. Okay, so just fill in with me and then submit it to me so that you can get the paper copy when you come back to school. All right. Okay, first things first. We've got four layers. We've got the crust, we have the mantle, we have the outer core, and the inner core. Okay, there's a lot more as you keep going in your schooling, but for seventh grade, there are four. Okay, they go down least dense all the way to the densest. So the crust is going to be the densest. The least dense. The crust is the least dense layer. Then goes the mantle, the core, and the outer core, and then the inner core. All right. So speaking about the crust first, it is located on Earth's surface. It's the outermost core. The outermost layer. And it is broken up into moving plates, okay? And we call these plates the tectonic plates. All right? And these plates float on top of the second layer, and the second least dense layer, which is called the mantle. All right. And there's two types of crust. They have continental, which makes up the continents, and then we have oceanic, which is the ocean. Okay. So continental and oceanic. Now, the thing about the oceanic crust is that it is actually it's thinner than your continental crust. Okay. So it's a lot thinner on the ocean floor. Now, the continental crust is typically made of granite. And if you remember from our rock unit, granite is our intrusive igneous rock, meaning that it's formed from the slow cooling of lava inside Earth's crust or on below the surface of the Earth. Okay, oceanic crust is made up of an extrusive igneous rock, which is called basalt. And remember, extrusive igneous rocks are formed when lava is cooled quickly. So those underwater volcanoes, they erupt, spew lava, it cools quickly and settles down. And this specific type is called basalt. All right. So it's our outer layer. It's also solid. Imagine that. We're standing on a solid. And the temperature is 700 degrees Celsius. All right. So it's hot when you get down towards the mantle, but right now it's pretty cool. We're good here. All right. The depth is 100 kilometers. All right. So it goes down about 100 kilometers. Moving on. So we have our crust, which is like a balloon. It's floating. It can move. All right. And then we've got our mantle. Now the mantle is has plays a really important role in plate tectonics, and that's because this lower part right here, the lower mantle, um, is heated up. So Earth's core is heating up this rock material in the lower mantle, and this material, as it heats, it becomes less dense. So I'm not saying like it's going to float out into space, obviously, but it's becoming less dense, and it starts to move towards the crust. All right, and it's floating to the top. So think of a lava lamp, all right? I don't know what lava lamps are made out of. I probably should look it up. But if you think of a lava lamp, in the beginning, it all settles down to the bottom, all right? And as you turn on the light, that starts to heat these blobs of whatever it is. If you know what it is, comment down in the comments, and that way I know. Okay. So as it is heated up, it becomes less dense because as you increase temperature, density goes down. density goes down. Okay, the particles become farther away. So it's moving up, and then as it reaches the top of that lava lamp, it's going to cool down because it's farther from the heat source. Same thing with the mantle. So the material that's been at the lower core, the lower mantle, is heated up and it's brought up towards the crust. And at the top, it's going to cool down and then it's going to sink because it becomes more dense. All right, and this cycle is called a convection current. Now, convection currents are the reason why our plates move. This movement of molten rock, or this movement of rock, is what causes all the tectonic plates and the earthquakes and all of that. Okay? Now, the location of the mantle is in between the core and the crust. So it's between core and crust. All right. And now it's still a solid, but it's kind of a flexible solid. I would consider it more of a colloid maybe because it still acts as a liquid. It's still able to move. All right. So it but moves. All right. Now the temperature is significantly hotter than the crust and it is at 3,500 degrees Celsius. And the depth is significantly more also. Let me get my notes so I can tell you exactly which one it is because I get confused between the two. And so the mantle has a depth of 2,900 kilometers. 2,900 kilometers. All right. Now we have so the really important thing about the mantle is that those convection currents, that rising and falling of the rock. Okay, so now we have our outer core. The outer core is going to be between the mantle and the inner core. All right. So it's sandwiched between there. Now, just like the crust is important because it holds life, the mantle is important because of the convection current. The outer core is really, really important to our everyday lives because it is the only liquid layer. It is the only liquid layer. And the reason why it's liquid is because it's super hot down there, but also there's not enough pressure to turn it to a solid. Okay, so there's not enough pressure for it to be solid. We're going to see that the inner core is a solid because of pressure. The outer core is a liquid because there's not enough. All right. So as the reason why that it's a liquid, and well, why it's so important that it's a liquid is because the flow of that liquid in the outer core causes the Earth's uh, magnetic grid, the magnetic field. There we go. Magnetic field. Okay. And it's really important. I really suggest you look into what would happen if Earth didn't have a magnetic field because it is complete and total chaos that would ensue. Okay. So it creates the Earth's magnetic field. All right. So our state of matter is liquid because it's the only liquid layer because it has enough temperature to be liquid, but not enough pressure to be a solid. And its temperature is a whopping 54,000. Nope. I'm sorry. 4,500 degrees Celsius. And its depth, so the depth of it is, excuse me, 51,000 kilometers. I got those mixed up. All right. So the crust, remember, is our least dense. It's like a nice, let's see, it's like a balloon. Okay. So it's light, it flows, it can float from side to side, it moves, it's very thin. We've got our mantle, which is kind of like oatmeal. Okay. Like it's pretty solid, but if you heat it up enough, it's going to kind of like separate. All right. And then we've got our outer core, which is all I can think of right now is hot chocolate. I don't know why, but that just sounds delicious. All right. So we've got our mantle, which can kind of move, and it's causing the balloon like crust to move. And then we've got our outer core, which is our hot chocolate. And our final one is the inner core. The inner core is located in the center of the earth. Surprise, surprise. And this is our most dense layer. okay? The most dense. And it is a solid ball of metal, okay? So it's not just some like bouncy ball. No, it is a solid thing. It's a solid thing of metal. It's like this ball right here. This isn't metal, but it's the closest thing that I have. All right. It's super heavy, it's super dense, and it is also very important. So it's comprised of mostly iron, and it actually spins faster than Earth itself. All right. So it's like a top. All right. It's spinning, it's spinning, it's spinning, and it causes the rest of the Earth to spin too. Oops. All right. So it spins faster than the Earth, and it is as hot as the surface of the sun. That's pretty hot. Spin. Let's make sure I have that spin. Okay. Now the state of matter is that it is a solid. Okay. It's a solid. And the temperature is a whopping 6,000 degrees. Not 600, 6,000 degrees Celsius. And it is at a depth of 6,400 kilometers. Okay. All right. So the other thing about the core, the reason why we know about this is not just because somebody decided to dig to the center of the earth. You know, the Rock Johnson definitely did a great job portraying that, but we did not go to the center of the earth. There are no dinosaurs that I know of, only very hot metal. Okay. But the reason why we have come about this is because of seismic waves, those earthquake waves, right? And as these waves pass through different materials, they act differently. So if you think about sound waves. You can hear things a lot better when you are underwater than when you are above water. And it's because that these sound waves travel faster through different things than other materials. All right. So we've investigated these really hot places because of the seismic waves and how they interact between materials, the pressure, and the temperature of those materials. All right, our last one. So we've got what happens to the temperature as you travel deeper and deeper into the earth. Well, if we look at all of this, we can see that it gets pretty hot. So as we go deeper into Earth's crust, we have more heat. It gets hotter. Okay. So make sure that you submit this to me. And if anybody knows what a lava lamp is made out of, please put it in the comments so that I know. And I will get you your paper copy once you get back to school if you submit this. Have a great day.